welcome. This is David Robison with Design Master, and today we are looking at dwelling unit load calculations in Design Master Electrical. These calculations are ones that we added a couple years back in one of our updates, and so there's a lot in the NEC about doing residential load calcs, and so we tried to capture as much of that as we could in our software. I think we got pretty much all of it in there. But because there's so many different pieces in the NEC, it does make it a little bit, you have to know what you're doing in order to get everything set up right. Just because, there's all the different options in the NEC, you want to make sure that where you're putting your loads corresponds to the appropriate setting in the section in the NEC so that all the calculations end up working out right. So we're basically looking at the dwelling unit portions of NEC 220, 42 through 85, both the main dwelling unit calculations and then the optional calculations in 220, 82, 83, 84. So we are going to start by looking at the settings you have at the panel level. So if I open up a panel here, and I'm going to make a new panel that we're going to work with. I will call this my A panel. And we have the feeder and service calculation settings. So this has options for getting your calculations set right for your feeder and service calcs. First choice here is the load calculation method. This is going to look at, is going to basically define what the basic calculation is going to be for the panel. What we're going to be doing with our lighting loads, and then if we're doing any of the optional calculations. So 22042 has the diversity factors for the different occupancy types for your lighting loads. So that's what most of these commercial options are for. If you've got a hospital or a hotel and you want to have your lighting load adjusted based upon those diversity factors, you can select those here. Looking at the residential, there is one option in the 220.42 for residential for dwelling units. So if you select that, you'll get the dwelling unit diversity for your light fixtures. Otherwise, for dwelling units, we have all of these optional selections. And this is basically where you're saying, okay, I'm not going to do the standard Section 3 calculation. I'm doing one of the optionals in Section 4, 220, 82, 83, 84, and 85. So if you select the optional dwelling unit, that is going to do the 228.2 calculation for a single dwelling unit, just using that optional method. And then there's a corresponding one for the existing, if it's an existing dwelling unit, where they have most of it the same, but there's a slightly different change to the calculation. So we can do those two different calculations. And then there's the option here, the optional multifamily dwelling. And then in parentheses, we have three different choices. If single unit, what should we do? So for 228.4, for a multifamily dwelling, that works if you have more than one dwelling unit on the panel, obviously. So because it's multifamily, and that's the whole point of it. So if you've got multiple dwelling units, we're going to do the multifamily calculation. But if you get down to a single dwelling unit, if you got a single panel feeding a single apartment or a single condo or something like that, we need to know which calculation to kind of fall back on at that point. And so there's three choices. You can just do the standard calculation from Section 3. We can do the optional calculation from Section 4 for a new, the 228.2, or we can do the optional calculation for an existing dwelling unit. So when you're doing multifamily dwelling, you want to choose, obviously, multifamily dwelling and then have the if single unit set as appropriate. Typically, it's going to be Section 3 or Section 4, depending on which calculation you want to use, and then we will fall back to that. There's a question in the chat. Which one do you recommend for apartment buildings? So that gets a little bit into engineering design intent, because you want to choose the one that is right for the building that you're doing. And so that's a question of opening up the code book, reading through all of these sections, and making sure you're understanding what each of those sections do. Our software is going to do the calculations, but we're not necessarily going to tell you which is the right calculation. Now, if you have an apartment building, you probably want to get into the multifamily dwelling in the 228.4, so one of these three options. And I think generally the 228.84, the optional calculation ends up being a little a lower load than the standard calc, so people tend to like that better. The clarification, I'm talking about the main service versus the unit panels. And so for that, so if you have an apartment building where you're obviously using the multifamily dwelling, the recommendation is to have them all set to one of these multifamily dwellings, where at the main service we'll know that there's multiple units being multiple dwelling units, so we'll use the multiple dwelling unit calculation. And then for the unit panels, we'll see that there's just a single unit, and then we'll fall back to Section 3 or Section 4 as appropriate. And you'll see that the load calculation method, you've got all these choices, and then the top one is default, and then in parentheses right now it says general. So that means that when you create a new panel in this project, it's going to be using this general calculation, which doesn't have any of this extra special stuff happening in it, just a fairly straightforward calculation. If you're doing something like an apartment, or you're doing basically anything else, and you want to use a different calculation method, you can change it for each panel, and that will work. It's a little simpler if you just change what your default is. And you do that in options. We also have this button here, Set Default, which will basically jump you straight to the options and allow you to set what it should be. So if we're doing an apartment building, we can set the calculation method to multifamily dwelling here, and then all of our panels will use this unless it's been changed off the default, but at least it's coming in with a good value. So for the purposes of this, we'll change our default to our multifamily dwelling there. Click OK. And so now you'll notice that we're still on default, but the default option has changed. So it's going to use that calculation method instead. So that's the load calculation method, and that's going to have a pretty big impact on how the calculation works. There is a corresponding schedule block, and the schedule block needs to match the load calculation method because the footer of the schedule is going to have different values displayed, and you need to have the values displayed that correspond with the calculation that you're doing. So what we're looking at here is on these panel schedules, we've got these footers here that are basically doing your service calculation, and so we need to have a footer that has the right values being displayed. Because of the way our customization is set up, you can have different options, so we can't necessarily know which schedule block exactly should be chosen, so you do have to choose that separately. It causes problems sometimes if you get a mismatch where you have one load calculation method being used and you're using a schedule block that kind of goes with a different calculation method. Things look weird until you get those matched up. So we're looking at some options for a future release to simplify that so that the footer always fills in with the right values. But for right now, you just need to make sure that you're choosing something that matches. In this case, we'd want to do one of the panels that are a multifamily dwelling. And I'm actually going to choose the one with the house loads, so that if there are house loads, those will show up. It makes the schedule a little longer, but if you have the loads, you obviously need to display them. I skipped over the default general lighting circuit value. That was intentional. We will come back and look at that after looking at a couple other things and looking at circuiting. So we will talk about that later on during the class. We also have here the multifamily dwelling units. This setting is the number of units that this panel is feeding. And you always want to set this at the lowest point in your one-line tree. So if you have a panel that's feeding a single unit, you want to, at that panel, set this to 1. And then at the upstream panels, if you got your main panel that's serving 100 of those single unit panels, you don't want to set the main panel to be 100. You want to leave it at 0 and have all the 100s, all the single values add up to 100 when it's connected. So basically, it'll add up all the dwelling units of everything connected to it. So don't, at your main panel, set the total number there. Rather, go to your sub-panels, set the number that is being fed by each sub-panel. So depending on how you have things set up, if you have sub-panels feeding individual units, you'll set this to 1. Maybe you have a panel feeding a couple of units, it could be 2 or 3. If you're not going down that far in your modeling, if you're just doing sub-panels that are serving 10 or 20, you could set that as well there. But then in the panels upstream, don't set the values additionally because you'll end up double counting. It'll be pretty obvious when you look at your totals that they're twice what they should be, and so you'll know to go back and change them. But it's simplest if you just set it up right ahead of time. I'm eventually going to create a couple panels underneath this one, so we'll leave that at 0 for the moment. The final set of options we have here related to dwelling units are these occupancy areas down here in the bottom. And this is the area of the building and then the basically general lighting demand for that area. So the NEC defines a number of different types of areas, gives them each a demand factor. We list those all here. We kind of group them based upon the power density, because that was the simplest way to put this whole thing together. So for dwelling units, those are typically 3 VA per square foot. So you put in the size of the area. And again, these areas are going to be added up. So if you have sub-panels, you set the areas of the sub-panels, and then the main panel will add up all of those areas. There are 2 places to specify your area. We've struggled with the labels on these because no matter what we label them, people still ask questions about it. We've done our best to do understandable labels. So it says that the NEC Table 220 demand area, the 220.42 demand area, so that is the area that is going to have the demand factor from NEC 220.42 applied to it. So this is what you would want a demand factor applied to. So this is the general areas are going to always be this top one. The 100% demand area means that no demand factor is going to be applied. You'll just get the full load from that area included in the load in the panel. That's mostly, there's a subnote on 220.42, a little footnote saying that if you got like a ballroom or an operating room where the lights are always on, that those need to be 100% demand, and so that's where you put these areas. So if you're looking at the footnote there, that's when you would specify these areas. But if you're not in that little footnote, you typically want to be up here in the 220.42 demand area. And then there's a question on the setting that I skipped. Is the future demand for when I'm just starting design and want additional capacity for changes? So there's 2 options here, metered demand and future demand, that I ignored because they're not specific to dwelling units, but I'll address them since they're here. So future demand is just additional load that you want included that's not connected to anything. The original design request was for just, you got your design completed, but you know that in the future there's going to be more added to this, so you want to have that accounted for in the project. So you can just put a future demand as a percentage or a straight kVA value, and then you'll know that your panels are sized to include that future expansion that's going to happen. You also could use it at the start of the project if you wanted to set a load, to kind of have some loads on things to see how it's all going to work out, and then back that off as the project goes on. So that would be a use that you could use for that, just to put a load on a panel that you eventually get rid of. And metered demand is when you have an existing situation and you've actually calculated the load, done the metering, and so you know what the demand is based upon the actual design, the actual performance of the building. You can specify that here, and then you get the 25% of the load, and that shows up. So that's NEC 228.7 is what that's trying to handle. Excuse me while I take a drink of water here. So those are all of the options and settings we have at the panel level. And then we have a number of settings at the circuiting level as well. And this is all of the load types that we have. So if I go to set fixed loads, we break our load types into two columns. We've got our general loads on the left and our dwelling unit loads on the right. So the general loads are typically just the non-dwelling unit stuff, your standard commercial loads. So that's where all your non-dwelling unit stuff goes. If you have anything that is kind of falling into a dwelling unit, you want to put the load over on the right. And it's important when specifying your loads that you get the things in the right spot so that we know where to put it when doing the calculation. For example, if you're doing a multifamily dwelling and you have some heating and cooling that's related to the dwelling units, and you also have some heating and cooling that's related to the house loads for the lobby or whatever, you want to put the lobby heating in the general loads and the dwelling unit heating in the dwelling unit heating loads. So it's important to properly separate those out so that the software knows what to do with it. If you use a load type that doesn't have a great correspondence to the calculation method that you're using, it sometimes won't show up quite nicely in the footer, and so it's mostly a matter of making sure that you get everything in the load type that it actually corresponds to the calculation you're using. So walking through these dwelling unit loads, they all have a specific NEC purpose for existing. So small appliance and laundry, those come into play both in the standard calculation and the optional calculation. In the standard calculation, I'm pulling up my NEC so I can remember where they go. Those actually get folded in to the general lighting. So the load based upon the area, we add these loads to it, and then you get to add your demand factor to that. There's also a statement that there's supposed to be 1.5 kVA for each circuit. So if you're connecting devices to these circuits, if they don't add up to 1.5 kVA, we always bump it up to 1.5 for each circuit with these types of loads. So you can just put a couple of them in, and it'll be 1.5, and it won't go over. If you have a large small appliance or laundry load and it goes over that 1.5, we will let it go over. So I'm going to go ahead and demonstrate that one just to clarify how all of that works out. So we will make sure that we've got our panel. We're going to do a standard dwelling unit calculation, and we've got 2,000 square feet of the area of the building, and we'll set our panel schedule here to match, and I want to do my dwelling unit. And if I insert that schedule on the drawing, and I'm going to do my update and update the calculations. You have to update the calculation to recalculate all these values because it takes a moment, so we don't do it all the time. So here it is. We've got that 2,000 square feet, which gives us 6 kVA of lighting. And then we've got the demand factor that's described here, so 4 kVA of total load on this panel. And now we'll add the small appliance and laundry. But first, there's a question. So can I configure the panel to ignore receptacle loads and use the fixed loads instead for laundry? What you want to do in that case, and I'll demonstrate how I would model it, and I think it will answer your question. So I'm going to go ahead and create some receptacles. And what you want to do, rather than leaving the load type as receptacle, because receptacle in our software has a very specific meaning where it's talking about 220.44, receptacle loads other than dwelling units. So if you have the load type set to receptacle, our software sees that as a non-dwelling unit receptacle where you've got the 100% and then over 10 kVA, 50%. So if you have it set to receptacle load type, that's what our software thinks that you're talking about. So if you're not using it for that purpose, if this actually is a laundry load, what you want to do is either create a different receptacle type or on the specific receptacle override it and say, okay, this is actually a laundry circuit. Change my panel description, and I'll put 2 of those receptacles in there over here in space. And now on that panel, I can connect both of those receptacles, and they were both the standard 0.1 kVA, 0.18 kVA. I didn't make any changes to it. You'll see that the load we bumped up to 1.5 because laundry circuits always have to be 1.5 kVA. So we saw that it wasn't, and so we just bumped it up. So that's how you really want to model your laundry circuits. Set the load type at the receptacle to be a laundry receptacle as opposed to a receptacle. Same thing for small appliance. So if I copy these, and then we're going to do an edit multiple. We'll change those from laundry to small appliance. So now I've got some small appliance receptacles. Do 2 circuits of small appliance here. So now we have those small appliance circuits, and then when we update our panel schedule, all of that will show up in here. So we've got the single laundry, the 2 small appliance circuits. That's added to the general lighting, and then the demand factor is applied to all of that. So for the general calculation for small appliance and laundry circuits, they end up in the general lighting, and we apply the demand factor. If you're doing the optional calculations, they basically there's basically 2 parts to the optional. There's the general loads and the heating and air conditioning. And so the general loads, you kind of add everything up and then throw a demand factor on it. And so part of the add everything up is all of the small appliance and laundry gets added into that. So we consider those as part of the general load so that everything just gets smashed in together there. So if we go here, we can change this. We're going to change it to the optional, the section 4 calculation. I'll change my panel schedule to match. And if we update our panel schedule, it'll actually swap out the schedule for us. And so now we've got a different calculation happening, where again you've got the 6 kVA from your general lighting. You've got the other small appliance and laundry. You've got your total, and then we apply the demand factor to that. Small appliance and laundry in general work basically the same. They're pretty much dealt with the same in the code. We have them as separate items because the code treats them the same, but it does call them out separately, and so some people like to see them just listed separately. We originally had them together as one, and people wanted to see them separate. So you can just call them out as separate load types, Not that anything is different other than that way you know this is a small appliance, this is a laundry. And so then there's another question. How would you set up receptacles in the living spaces? So we've got our laundry room over here. We've got some small appliances over here in this room in my wonderful non-drawn building. So then we've got a living space here where we need to have some just receptacles. Now those receptacles end up in the general lighting load. So they're included in that 3 VA per square foot. So the question is, how do you handle all of that? So let's take these 3 receptacles here, and we're going to change those. Now these ones, it's not going to matter what we choose for our load type, because it's eventually going to get ignored, because we don't have a general lighting category here. So for those, you can just leave them as a receptacle load type or whatever they happen to be, because it's eventually I'll show you it's not going to end up mattering what their load type is. The panel description does matter because that will still show up in the circuit. So we'll leave that as receptacle. And now I can circuit those to another open circuit here. So we've got those 3 receptacles. The description has shown up there. Excuse me for a moment. I'll take another drink of water. So we've got the receptacles on that circuit there, but they are part of the general lighting. And so we don't actually want this 0.5 kVA to show up anywhere. If we don't do anything, and let's see, if we change this back to a standard calculation, update our panel schedule as well, our calculation, you can see that we've got the 5.63 of general lighting, and then it's not listed anywhere because they're receptacles and they're not actually listed in this footer at all, but our total is actually 6.1. It's got the extra 0.5 kVA being included there. And you don't want that to happen because these are just general receptacles and they should be included in that general lighting. So the way that you handle that is in circuiting. There is the general lighting circuit option, and you want to change that from no to yes. And what this says is it says that whatever is connected to this circuit, we are going to ignore at the panel level. So we'll still do all the circuiting loads. We'll give you the load and the description. But when we do our feeder and service calc down here at the bottom, that load is totally ignored. And that's specifically to handle your receptacles and also the lights, because if you put in a bunch of lights, they're obviously included in your general lighting load as well. So you want to set that to a general lighting circuit. This was the option that I was saying I skipped over, so we're getting back to what I had skipped there, because it makes the most sense at the circuit level. So these circuits have that set to, in this case, default, which is no, and then we've overridden it for this one circuit to say yes. Now we've got multiple places where you can set the default. So the simplest thing is to have the default be no, and then the ones that are general lighting circuits, set them to manually set those individual circuits to yes. You can flip it and have the default be yes and then manually set the other ones to no. My sense is that that's probably more work to do it that way, but you can do it whichever way you want. To set the default, there's a default at the panel level. So this setting that I skipped over is the default for this panel for all of the circuits in it. So that if it hasn't been overridden as yes or no, what is it going to default to? And then there's also another default at the project level. So this panel is set to default, which means it's not actually pulling it from the panel, it's pulling it from our options and what the default is in the options. So you can have a default setting for the whole project. You can then override that for specific panels and have a default for each panel. and then always on each individual circuit itself, you can set a specific value. So that's all for setting general lighting circuits, basically the circuits that you want to ignore when you're doing your calculation because they're included in that area calculation. All right, so we have looked at small appliance and laundry. Just a couple more to go here. The next option is appliance, which is different from small appliance. So appliance is NEC 220.53, where if you have 4 or more of them, you get a 75% diversity factor. So you can specify the load here, and we break it down into continuous and non-continuous so that at the circuit level, we size the breakers differently for continuous and non-continuous loads. So if you want to take that into account, you can have the different load, and we'll do your breaker sizing. 125% of continuous loads, 100% of non-continuous when sizing your breakers. So you can specify what type of load it is. We also have the multiplier, and this is how many appliances are on that circuit. If you don't specify anything, we assume it's 1. There's just a single appliance, but if you had multiple appliances on one circuit, this is where you could say 2 or 3 or 4, so that we knew then basically we add all those up, and once we hit 4, then we apply the demand factor for you. So if I put a single appliance here, call that appliance 1, and we'll do this appliance 2, and we'll put another appliance load there. When we update our calculation here, you'll see that we've got those 2 kVA of appliance loads. There's only 2 of them, so we're still at 100%. If we then go back to our circuiting, and I'm just going to change this one, change the multiplier from 1 to 3, so there's 3 on that circuit, 1 on the other circuit, 4 total for the panel. We update our calculation, and now we have more than 4, so we get the 75% demand factor. When you are doing the optional calculations, those again just end up wrapped up into the general load. So that's where we end up putting those. Oh, and then we also have appliance motor. Same thing, whereas if you have an appliance that is a motor, you can specify the value here, and then when we're looking at our motors trying to figure out what your largest motor is, we will consider that as an option. It's always considered a single motor. We don't have an option for the other motors like we do for the cooling and the regular motors. So the assumption is that if you have an appliance, we just simplified it and say, okay, this is just going to count as one motor. And so if it's the largest, we'll count it as the largest motor. Then we have the electric dryer, which has, again, its own section of the NEC, 220.54, with the demand factor based upon the number of dryers. It has a whole table rather than just a fixed cutoff like the appliances. So again, you set the load and you set the multiplier, which is the number of dryers. And then we'll do the calculation for you and give you your demand factor. For both of those, go ahead and show you. So we were looking at the fixed loads there. But if you have like a receptacle that represents that dryer or the appliance, first of all, when you set the load type, we remind you that the demand factor represents the number of dryers. So we have a little reminder that that's what that does. You can eventually turn that off if you get tired of it. But this is where you would set the number of dryers represented by this receptacle. Typically, it'll probably just be 1 because you have 1 dryer being plugged in. But if you had another situation, if you had a junction box where you're kind of modeling a bunch of loads in one spot that you want to connect at once, you could set this to something higher. So that's where you specify the number of dryers on a specific receptacle, and same with appliances. Just want to show how that is done at the device level if you're working on devices as opposed to fixed loads. And then we have electric cooking, and this is the dwelling unit cooking, which is separate from the kitchens, the commercial kitchen. So the commercial kitchen is over here, and then the dwelling unit kitchen stuff is over here. So just make sure that you know what type of kitchen stuff you're working with and specify the load appropriately. And that, again, is based upon the number of items, and so you have the multiplier here as well that works the same as the dryer and the appliances. And then we get down into heating and cooling. We'll look at the heating and cooling, and in general, we take the largest of the two, and we use that at 100%, and then the others at 0. For the optionals, which we'll look at, it gets a little more complicated because they have a couple other options happening. But in general, we just look at the two and take the largest of it. So for heating, for the standard calculation, this multiplier isn't really going to matter because we just take the heating load as it is, and there's no demand factor. In the optional calculations, there are different sections based upon the number of space heating units you have. And so this is where you can specify the number of units of space heaters there so that we know which little section of 220A2C, there's the different options. We know which one that you want to use. So if you change your multiplier, it'll basically say there's more space heaters on that circuit. So we'll count up the number there. Cooling is broken down into largest motors and other motors. So that the largest motors, basically, if this is a single motor, we'll count it, we'll look at it as a single motor, and so if it's the largest of the largest motors, we'll use that as the largest. In other motors, it assumes that that's a bunch of small motors, and so even if this value is larger than the largest motors, we're going to ignore it because we assume the largest motor is still larger. And then there's the question in the chat, how does it break out unit heaters versus heat pumps? And heat pumps fall under this final category, which is heating and cooling motor, which is basically heat pumps, but there's a couple other things that could fall under there too, so we made it a little more universal and called it heating and cooling motor. It's basically a heat pump. And so this is a motor that runs in heating and cooling mode. So you specify your heat pumps here. In the standard calculation, there's nothing specific about heat pumps, so it just gets treated as a heating and a cooling load, and also as a motor if it's the largest load. For the optional calculations, where it does specifically reference heat pumps, we assume that that includes the heat pump is the whole load and the heating and cooling motor. And then the follow-up question, so heating is for radiant heaters, and heating and cooling is for central heat pumps or furnaces. I think the answer to that is yes. I think you're understanding that correctly. I think I'm understanding your question correctly. That, yeah, you've got your heat pumps, that's heating and cooling motors. Yeah, your radiant heaters, your space heaters, that's all under heating. I'm going to pause for a moment and take another drink of water here. The final load here is the marina, mobile home, RV load. All of those have slightly different calculations even from dwelling units, and so there's usually a load specific to that type of thing. We're not going to cover that because that's getting into stuff that I don't think a lot of people are doing. So if you're doing marinas, mobile homes, or RVs and you do have questions, you can follow up with an email to support@designmaster.biz afterward, or give us a call, and we can talk to you more specifically about that. But I'm just going to gloss over that and ignore those calculations for now. Before we kind of continue rolling along here, I am going to take a pause for a moment and see if there are any other questions that anyone has. Anything you specifically want to see? We've got some time here, so that we can cover some more. But if there's anything specifically you wanted to see on dwelling units that you haven't seen yet, take this moment to put it in the chat box so I can make sure that I cover any questions that you specifically have. Are exhaust fans entered as an appliance motor? I'm thinking about the answer to that question, and I believe the answer is yes. And I think that actually was the motivation, that the specific example that motivated that category. That exhaust fans are appliances, so you want that 75% demand, but they're also motors. So if they do, if you've got a bunch of exhaust fans and that's the largest motor, you need to have that accounted for as well. So I think that's probably the best spot for them. And that's mostly going to have an impact for the general calculation where you're doing Section 3. If you're into Section 4 where you're doing the optional calculation, exhaust fans just end up in the general loads, so it doesn't hardly matter what you've chosen, because for those calculations you just add everything up and then 100% for the first 10 and 40% after that. So it just kind of gets grouped into the general loads. For the multifamily dwelling, that's the same thing. So it's less important there. It's mostly when you're doing your just a standard calculation that becomes an issue. All right. I want to demonstrate the multifamily dwelling stuff while we have a moment to do that. So I will do that next. So we've got I'm going to actually make a new panel. I'm going to make my main panel, and then I'm going to have two sub-panels on it. And this is going to be a multifamily dwelling unit, which is what I want, which is good. So we've got that. And we'll set the panel to the multifamily dwelling. So this is going to be the main panel where our sub-panels connect to, so I'm going to leave the multifamily dwelling units at 0. I'm going to create my sub-panel. And I'm actually going to call that sub-1 because I'm going to have multiple of them. Here, the load calculation method, we leave the same. We're going to say this is a single dwelling unit. So for the schedule block, rather than choosing a multifamily dwelling schedule, because it is just a single dwelling unit at this point, we actually want to choose the dwelling unit schedule instead. So you need to be a little bit careful when setting your schedule blocks for multifamily dwellings when you get down to the single unit panels. And we'll say this is 1,000 square feet for this panel. And I'm going to make a copy of that. And I'll make 4 of them. So now we've got 4 sub-panels, and then we'll connect those up. I was using main for this. Not the most exciting part where I connect panels together. I need to do this so that all the calculations work out right. If you do have a number of panels that are all the same, we have the recurring panel template and instance feature. We are not going to be covering that today. That's something we'll go over another time, but that's for where you've got multiple apartments that are all the same, where you can create all those panels and have them update automatically. Wouldn't the sub-panels be single phase? If I was a better engineer, they probably would be, but this is just a demo and not an actual design. So don't copy my design here. Because single phase versus 3 phase isn't going to have any impact on the calculations I'm showing you. I just left it like that. Partly because I'm lazy and partly because I'm not as attuned to those differences as you guys are, because I don't do this design every day. So ignore my minor mistakes like that. the calculation here will work out the same. So we can insert those schedules. I'll put in my main panel, and then I'll put in my sub panels. We'll put them all down here. And those are all going to look the same, so I'm not going to put them all in. If we update the load on this main panel, you'll see that it's added up all of those areas. So we've got 4 of them at 1,000 square feet each. We've got the 4,000 square feet. We've figured out that there's 4 of them. And then we looked up that demand factor, so we've got the 45% demand. So that ends up there with our total calculated load. So that's the general idea, the general workflow for setting up your sub-panels in a multifamily dwelling situation. And then you'll notice we've got all these house loads so that if you do have a lobby or something like that, when you specify those loads, they're going to show up separately and be calculated separately. So if we come in here and we go to our main panel, and I'll go ahead and put just a 5 kVA heating load. You'll see that that's going to obviously show up down here in this heating, and it's not up here in this heating. And then we do the total down here for the dwelling units and the house loads, give you the total for the panel. Take another drink of water here for a moment. All right, I think I have covered what I intended to cover for dwelling unit calculations. What did you use for the main schedule? So if we pull up that main panel, I chose, so our schedules, we basically have panel with phase breakdown, panel without phase breakdown. So the with phase breakdown is basically ends up as a slightly wider schedule. The without is a little more compact. And then we've got all the different types here, basically which footer is being used. And I had chosen the multifamily dwelling with house loads. So that's the choice that we have there. So that includes the multifamily loads and then the house loads separately and then the totals. So that's in there. So that's what I chose for that one. And then, do you have a webinar that outlines how to customize the panel schedules, headers, bodies, and footers? We do not have a webinar about that, but that's a good topic idea that we can tackle one month to look at how to make changes to those schedules. We did do, I'm trying to think, I know I've done some customization, but I don't know, I don't think we have anything on that currently. But I am making a note of that right now for the future. Panel schedules, we have the defaults, and they work, but some people like to show different things, and we actually can show a lot of other different values beyond what our default schedules show. So there are quite a few options to show other things there. And then another question, if you connect an appliance motor load, for example, an exhaust fan, to a circuit tagged as general lighting, will it ignore the fan? And the answer to that question is yes. And to clarify or expand on that a little bit, in your circuiting, whatever loads, if you have your general lighting set to yes, whatever loads we put here are ignored at the feeder level, at the panel level. So we use it for sizing the circuit, for the breaker, for displaying the load, but for the actual panel, it's totally ignored. So, for example, we could have 1,000 kVA largest motor here. It's going to complain because that's super huge. But it's not going to even see that as a motor and count that as the largest motor because it's part of the general lighting, so it's just not going to get counted. So if the general lighting circuit is set to yes, it is ignored, and it's part of that 3 VA per square foot. Hopefully everyone sees those survey links and can click on those for me. Particularly would like you to do the BIM survey just so I can get a couple more responses on that. And then the weekly training, obviously, if you have suggestions, you can make those there. You're also welcome to always email or call with either suggestions on training or if you have any other questions beyond what we've talked about here. We're always happy to help you out with whatever questions you have. But we're hoping these trainings are helpful to give you some more understanding of the software as well. Seeing any other questions then? So thank you all for coming.